Okay, we hear different terms like biodegradable, compostable, bioplastic, bio-based, and biopolymers. Can you clarify these terms?
It can be incredibly confusing and is really ripe for greenwashing by producers, and consumers can often be quite confused. So in our study, we were measuring how these items fragment after they're in the environment and exposed over time. An item can be biodegradable technically, but biodegradable where? This means that
Welcome to Captain Forest podcast Heroes Voice. Captain Forest is an international movement for a plastic-free, waste-free and permaculture world.
Hello, welcome to Heroes Voice by Captain Forest. Today we are happy to welcome Lisa Erdle, who is the Director of Research and Innovation at the Gyres Institute. Lisa Erdle is going to help us understand the various terminologies and answer this question: are bioplastics better than plastics? Manufacturers of plastics and consumer goods heavily promoted single-use plastic as a convenient and time-saving solution, encouraging a culture of rapid use and disposal. This shift in consumption patterns generated a cycle of mass production and consumption of single-use plastics. Despite the extensive production and consumption of single-use plastics, only a small percentage of plastic waste is recycled, less than 9% since 1915. Beyond plastic's non-recyclability, toxicity is another pressing concern. The non-recyclability and toxicity of plastics threaten the environment, animals, and human health. With the global issue of single-use plastic threatening our planet, bioplastic emerged as a promising alternative. However, there are various terms to traditional plastic packaging, like biodegradable, compostable, bio-based, and biopolymers, which can lead to confusion and greenwashing. So Lisa, two common issues with plastics are their non-recyclability and their toxicity. Can you tell us more about it?
Yeah, we just wrapped up a study where we had 22 different products in 6 different environments looking at their degradation. And what we found was many of these novel bioplastics behave much more like biological materials than technical materials, meaning that they were more similar to their natural counterparts, things like paper and bamboo that we tested, than like these traditional plastics. There can be a lot of variability in bioplastics depending on the polymer. It allows or doesn't allow microbes to get into these spaces and mineralize this material. But there are some items like thin films that we found broke down quite quickly compared to thicker bioplastics or some of these older polymers that were much denser and didn't have as many opportunities for microbes and bacteria to colonize the material.
Okay, we hear different terms like biodegradable, compostable, bioplastic, bio-based, and biopolymers. Can you clarify these terms?
It can be incredibly confusing and is really ripe for greenwashing by producers, and consumers can often be quite confused. So in our study, we were measuring how these items fragment after they're in the environment and exposed over time. An item can be biodegradable technically, but biodegradable where? This means that it'll break down to its component parts. It'll mineralize. So essentially this item is turning into its natural molecules. But is it biodegradable when it's in an ocean, in a lake, in a river, in the soil? Or does it only biodegrade under certain conditions of temperature and moisture, etc.? So an item can be technically biodegradable, just as an item can be technically recyclable, but does it actually biodegrade in practice in compost streams or in the natural environment? There are more and more labeling schemes that meet certain regulations. One like backyard compostable. That tends to be the most stringent, because while an item can be technically biodegradable, it may not biodegrade, say, in a backyard composter or in an industrial composter in a city. But those items that meet these backyard compostable regulations, these are a standard that needs to show a certain level of degradation in a backyard composter and meet those regulations. For these items, they are often bio-based, meaning that they're made from plants and not fossil fuels. But you can have traditional plastics, things like polyethylene, that are bio-based, meaning that they're coming from sources like corn instead of fossil fuels. So there can be a lot of confusion. Something that's bio-based is not necessarily biodegradable, and something that's biodegradable might only be biodegradable under certain environmental conditions. So I think it's an area that's ripe for regulation to try to cut through the confusion and really give consumers and brands truth in advertising to make sure that these materials actually do what they say they do, rather than giving these false claims or false hope that an item will, say, biodegrade if it gets into a lake or an ocean, when really it'll only biodegrade under a very narrow set of environmental conditions.
Okay, thank you. So do you think bioplastic are the answer? And I think also that you have some lesson learned from your case study. Can you share them with us?
Bioplastics may be the answer for a narrow set of products. Some items that we tested, these thin films, like PHA, degraded quite quickly in the environment. Thicker bioplastic items degraded much more slowly. And even though they showed a lot of surface texture changes and became more pliable over time, that material still persisted. So what this tells us is that some polymers are better than others at degrading. Some of these novel materials can break down quite quickly, especially when they're thin. This also informs design on how materials are made. There could be things like, instead of a solid cutlery handle, it can have other types of design, like a honeycomb structure that allows more area for these microbes to colonize. So what we are really advocating for is some of these hard to replace items. Bioplastics can be the answer. And as we transition to reusable economies, there might be a good replacement for some of these items, as long as they're designed with end of life in mind and can break down in waste management streams like compost or in recycling, if that's how they're collected. But there needs to be a lot of thought put into what is the end of life scenario. If it can be backyard composted and go into all compost streams, then great. But if these items are so thick that they don't actually degrade in those types of conditions, then they might not be a suitable replacement, and they could contaminate waste management streams like compost.
Okay, thank you. Can you just share a few examples of better alternatives?
In our study, we tested 22 different products, and some of the better alternatives that we found in our study are thin films made from these novel materials like PHA. These are items that degraded, within a matter of months in most of the environments where we tested them, in different environments, both aquatic and terrestrial in the United States. So this can be a better alternative to fossil fuel-based thin plastic packaging. But there needs to be care put into what sort of chemicals go into them. We tested a lot of raw materials, so raw PHA. The addition of additives can increase the longevity of these items in the environment, but can also impact its toxicity. So there needs to be a lot of care put into how these materials are designed to make sure that they are truly better alternatives than the ones we have now.
Okay, any word to conclude this interview?
I'm hopeful that material replacements can be used in some cases. We're not going to take all the plastics in the world and replace them with bioplastics, but for certain uses, to improve recovery of compost, to change out things like thin films on meat, and to ultimately transition away to more reusable economies, I think these materials can play an important role, and I'd like to see them put into practice.
Thank you very much, Lisa, for being with us today. And thank you everyone for watching us, and see you soon for a new episode of Hero's Voice by Captain Forest.